Okay, thank you and welcome to this Power Series Lecture 2. In Lecture 1, we were able to find the series for sin x, which was given by x minus x cubed all over 3 factorial plus x raised to 5 all over 5 factorial minus x raised to 7 over 7 factorial plus x raised to 9 all over 9 factorial minus x raised to 11 all over 11 factorial. It continues like that. So we were able to come up with this series of sin x in our first lecture. But remember, it took us a lot of time and a lot of effort for us to arrive on this series. We say that we have a much faster way of doing it. The one we are calling the chain resolution, the Maclaurin series. It uses less effort to arrive to the solution. So in today's lecture, we want to consider what we are calling the Maclaurin series. We consider the general solution, and to start with, we repeat the process of finding sin x as we did in lecture 1, but we shall use the general function f of x. We use the general function f of x instead of sin x, and as we use the general function f of x, we shall the first derivative of f of x, the first derivative of f of x shall be denoted by f of naught prime. The second derivative will be denoted by f of double prime. Then the third derivative will be denoted by f of triple prime, and so on. Therefore, we shall let f of x equals to a plus bx plus cx squared plus dx cubed plus ex raised to 4 plus fx raised to 5 plus it continues like that. So at this point, remember, if you want to get the series, we need to get the values of the constant. So here we shall let x equals to 0, or we put x equals to 0. So when we put x equals to 0, we substitute in this expression. So here we shall have f of naught equals to this is a plus b times 0 plus c times 0 squared plus d times 0 cubed plus e dot 0 raised to 4 plus f times 0 raised to 5. It continues like that. Therefore, because here we are multiplying with the 0 all through, so all these will be 0 up to that point, and then we remain with a equals to f of naught. Now we have the value of a. We can write it here that a equals to f of naught. Then we want now to get the value of b. Now we differentiate this equation. So when we differentiate this equation, we shall have f of double f of prime x equals to, this is now a constant. When you differentiate a constant, you get 0. So we have, when you differentiate x here, you get 1. 1 times b, then we have b. Then plus, when you differentiate x squared, we have there, we shall have 2 times c times x. Plus, when you differentiate x cubed, you shall have 3 times d times x squared. When we differentiate x raised to 4, we shall have plus 4 times e times x cubed. When we differentiate x raised to 5, we shall have 5 times f times x raised to 4, like that. And then once we have differentiated, we put x equals to 0. Therefore, here we have f of naught equals to, so here it will be b, then plus. So you can see that when you put x equals to 0, so from here all these will be 0 because we are multiplying with the 0. So we have b plus 0 like that. Therefore, here we shall say that b equals to f of prime naught. So b equals to f of prime naught. So we also want to get now the value of c. So for us to get the value of c, we now differentiate this equation again for the second time. So when you differentiate this equation, we get f of double prime x equals to, this now a constant. When you differentiate a constant, you get 0. So we have this. So when you differentiate x here, you get 1. So you have 2 times c times 1. So we remain with 2c plus. When we differentiate x squared, this one, so we have 3 times, now we multiply by 2, multiply by d, multiply by x, then plus. When we differentiate x cubed, here we have 4 times 3 times e times x squared, then plus, when we differentiate x raised to 4, here we remain with 5 times 4 times f times x cubed. Then once we have differentiated, we now put x equals to 0. Therefore, here we have f of double prime naught equals to 2c. So because here we are multiplying by 0 now, so all these will be 0, and then we remain with the 2c. So here you can see that now c equals to f of double prime over 2 factorial over 2 factorial. So c equals to f of double prime over 2 factorial. Now we have gotten c. We now need also to get d. So to get d, we differentiate this equation again. So we have When you differentiate f of x double prime, we get f of triple prime x, which equals to, now this is a constant. When you differentiate a constant, you get 0. So we have this. When you differentiate x, you get 1. So here we remain with 3 times 2 times d, then plus, we have, when you differentiate x squared, you get, here we shall have 4 times 3 times now 2 times e, then times x, then plus, when you differentiate x cubed, we have 5 times 4 times f times 3, this 3, we multiply by 3, then times f, then times x squared. Then we put x equals to 0. Therefore, here we have f of triple prime not equals to, now here we have 3 times 2 times t. Then because we are multiplying by x and x we have said is 0, then this will be 0, this will be 0. So this is what we have. Therefore, d, you divide through by that, d will be equal to f of triple prime over now this 3 times 2, which is 6, over 3 factorial. Remember 3 factorial is the same as 6. So d equals to 3 factorial. Now we have d. Now we want to get the value of e. Now to get the value of e, we now differentiate this equation again, so that we have, when you differentiate f of x triple prime, we get f of x raised to 4, which equals to, now when you differentiate, this is now a constant. When you differentiate a constant, you get 0. So we remain with this. When you differentiate x, you get 1. So 1 times this, we remain with 4 times 3 times 2 times e. Then plus, when you differentiate this, you get 5 times 4 times 3 times now 2 times f times x. So once we do this, and then we put x equals to 0, therefore we have here 0 equals to, now here we have 4 times 3 times 2 times e, then plus. Now because here we are multiplying by 0, all this will be 0 plus 0. Therefore, this is e. So e equals, we divide through by this, e equals to f of prime raised to f of x raised to naught, then over. So this is 4 factorial, 4 times 3 times 2 times 1. So this is 4 factorial. So e equals to, remember d here equals to, was that 3 factorial, and then e equals to over 4 factorial. Now, so we are remaining with it. We now need to get the value of f. So for us to get the value of f, we now differentiate this equation. Differentiate this equation again. So when you differentiate f of x raised to 4, we get f of x raised to 5 x equals to, now this is a constant. When you differentiate a constant, you get 0, so we remain with, when you differentiate x, you get 1. So we multiply through by 1, so we have 5 times 4 times 3 times 2, then times f. Now to get the value of f, we divide through by this. Therefore, f equals to f of x raised to 5. Now before that, we put x equals to 0, so that here we have f of equals to 5 times 4 times 3 times 2 times f. So f equals to f of, then over, now this is 5 factorial. Now, so we are saying that f equals to f of over 5 factorial. Now you can see that here is 5 times 4 times 3 times 2. So when we talk of factorial, 5 factorial is the same as 5 times 4 times 3 times 2 times 1. When we talk of 3 factorial, this is the same as 3 times 2 times 1. When you talk of 6 factorial, this is the same as 6 times 5 times 4 times 3 times 2 times 1. So you should understand the factorials. Now we have all now the constants from this from this expression. So we shall say that f of x will be equal to, now a is f of naught, a is f of naught, then plus b is what, f of naught prime. So here we have plus, we have that, then we have x, this is x, then c is this, so we have c plus c, which is f of double prime all over 2 factorial, then x squared, then plus, now d is all over 3 factorial, then times x cubed, then plus e is f of all over 4 factorial, then we have x raised to 4, then plus f is all over 5 factorial, then times x raised to 5, then plus. So it continues like that. So this is what we are calling Maclaurin's series. Maclaurin series. So that when you've been given to get a series of any function, so you don't need to do a lot of calculation, a lot of derivatives. So you only need to apply this formula, so that this series, so that you can get, for example, if you've been asked to get the series of sine x, or you've been asked to get the series of cos x, or the series of tan x, or even the series of ln of, say, 1 plus x. So this is the general solution that will be that we shall be using to get the series of various functions. Thank you for listening.